So good morning. So we were discussing about the various elementary signals, and in the last class we have seen what was the parabolic signal, unit parabolic function, and then in detail we explained what is the analog analog uh, delta function. Okay, analog delta function has it's a complicated signal. It is defined as an integration. That why it is an integration, the area under this curve or the pulse is should be equal to 1, and we have seen the limiting case also, that is when delta tends to 0, the height of the pulse tends to infinity. Okay, and interestingly, one interesting characteristics of this function was that it only had one value in the entire time scale. It has only one value, that is it is at t is equal to 0. That is delta of t has a value, only one value of height 1 at 0, or for all other time values it is 0. Okay, and if it is delta of t minus a, it's known that the starting point, or the point where a function has started, is actually the argument. The position is argument should be equated to 0. So here there is only one point, there is only one value, that is at t minus a equal to 0, that is t is equal to a. Now we have some very interesting conclusions from this function. This function is used widely. We'll see several examples also. So we'll see some of the properties. See, one very important characteristic is that delta of t is an even function. I'll come to this a little bit later because we are coming to the main properties or all those things. Okay, even function, we'll come to that. Okay, now the thing is that, see, this one is very important. See, if I multiply, okay, see, the second property, if I multiply any signal, x of t is any analog signal, with delta of t dt. So from integration from minus infinity to infinity, delta of t dt, we know what is it. Okay, its value is 1, and its value is 1 when t is equal to 0. That is integration from minus infinity to minus infinity to infinity, delta of t dt is equal to 1 for, and it is having only a value at t is equal to 0. What is that value? It is equal to 1. Okay, so when I multiply such a signal with any input, any signal x of t, then what is the case? Since this has only one value, and that too at t is equal to 0, since all other values are 0, 0 multiplied by the signal value will be 0. So out of this entire signal, only one point will be coming as the output. What is that one value? That is the value of the signal at t is equal to 0, that is x of 0. Why? Because this entire function has only one value, that is at t is equal to 0. So even though the signal is from minus infinity to plus infinity, but since this is having only one value, that too at t is equal to 0, then the signal, when we multiply such a signal with x of t, then we'll only get the value at t is equal to 0, that is x of 0, since this function is having a value only at t is equal to 0. I hope this is clear. Now suppose again I have the same signal x of t. I have another delta function. This time it is not delta of t, this time it is delta of t minus t naught. Then what happens? See, we know that what is delta of t minus t naught? It is having a value 1, that is only at t is equal to t naught. This integration from minus infinity to infinity, delta of t minus t naught dt is equal to 1 at only a point t is equal to t naught. So there is only one value, that is at t is equal to t naught. So even though I multiply such a signal x of t, which spans from minus infinity to plus infinity, what I'm getting is that when I find the product, we'll get a value of x of t only at x of t naught. So I'll get the result as x of t naught. Likewise, this one also, the same thing, we'll get it as x of t naught. Okay, that means if I want to get if I get x of 0 here, x of 0 multiplied by delta of t, I'll get simply x of t naught. Another corollary, that is, if x of 0 is multiplied, if x of t, that is equal to x of t is multiplied with delta of t, it is equivalent to x of 0 being multiplied with delta of t. Okay, now, so this is a very important conclusion, that is any value of the signal, any value at a time, multiply by delta t will be equal to that value itself. That is, any value of the signal at a time, when it is multiplied with delta of t, will get x of 0 itself. Okay. So x of 0 multiplied delta of t is same as x of 0. Now we'll go to the digital impulse. It's a digital impulse is very simple, nothing complicated like analog signal. That is delta of n equal to 1 for n is equal to 0. Otherwise that is equal to 0. That is, it is having only one value. It is having only one value, that is at n is equal to 0 with a height of 1. No other samples is having values. All other samples is having 0 values. Okay, suppose if I have n is delta of n minus k, delta of n minus k, what is the conclusion? This is having only a value at n minus k equal to 0, that is n is equal to k. So it is having only one sample of height 1 at n is equal to k. That is, suppose we have delta of n minus 3, then it is having only one sample of height 1 at n is equal to 3. Okay. Now this is a very important this I will show like little bit later, because see, same thing, that is I'll go little back, that is yeah, we'll see what is u of n. This is my u of n, this is my u of n, that is it starts at 0, it's all ones hereafter. Okay, there is nothing behind 0. What is u of n minus 1? U of n minus 1 means it starts at n is equal to 1. From there it is all ones. That is, u of n starts at 0. From there it's all ones. But what is u of n minus 1? Delayed by one sample. That is, my signal starts at n is equal to 1, and thereafter it is all ones. Okay. So if I subtract such a u of n minus 1 from u of n, if I subtract u of n minus 1 from u of n, what will get? We'll get only this sample. Okay. That is, when I subtract u of n minus 1 from u of n, I'll get only this sample. All other samples 1 minus 1 0, 1 minus 1 0, 1 minus 1 0. Only one sample will be there. Okay, without cancellation. That is at n is equal to 0. Okay, now coming back. So what is it then? I can conclude that it is okay. That is, I'm having, when I perform u of n minus u of n minus 1, I'll get only one sample of height 1 at n is equal to 0. That means that is simply delta of n. Okay. So delta of n is having a relationship with step input, that is u of n minus 1. Okay. Now we have all those things here. Now what is the likewise, what is this one? Okay, this is a discrete type. There is in analog, that is continuous domain, we had integration, but for discrete time in time domain, discrete time domain, we have summation instead of integration. Integration is only for continuous functions. For discrete functions we have summation. If you perform a summation from k is equal to minus infinity to k, that is minus infinity to infinity, that is if I multiply x of k with delta of n minus k, so this k is the iterative constant. I am iterating this k value from minus infinity to infinity. Okay, so what happens? We'll get, okay, I'll come to this. This is a very important operation. I'll come to this operation a little bit later. Okay, now what is this one? See, I am having delta of n minus n naught. That meaning is that this is having only one value at n naught of height 1. So even though I perform my summation for all values of n from minus infinity to infinity, I am having only one sample of delta at n naught. So when I multiply all other values as 0, so what happens when I multiply x of n with delta of n minus n naught? I'll be getting x of n naught, because all other products are 0. There is only one product which is having a value, and that is x of n minus n, x of n naught. Why? Because this function is only having a value at n is equal to n naught. Okay, now coming to the next important signal, that is sinusoidal signal. What is sinusoidal signal? Sinusoidal signal is a very, very well-known signal. We have seen many a times in AC fundamentals. That is x of t is equal to a sine omega t plus phi. Okay, so a defines the amplitude. It's a sine function, sinusoidal variation. Then omega is nothing but the angular frequency. Variable is time, and this is a phase difference phi. Okay, so these are well-known quantities, so need no explanation. Okay, so this is how it looks like. One thing is very important. What is the time period? That is, Time period is given by 2 pi by omega. Okay, that is, what is time period? That is time taken to complete one cycle. Okay, what is one cycle here? This is one cycle. So this is one cycle, one complete pattern. This is the smallest repeating pattern. Smallest repeating pattern defines the time period. See, there is a confusion. That is, this is one pattern. This complete thing is one pattern which get recurred, which is also getting recurred. But that is not the time period. Time period is the smallest pattern. This is the smallest pattern which repeats again and again. So that is how time period is defined. So what is time period? Time period is nothing but 2 pi by omega. Likewise, in the same way you can. So one thing is sure, analog sine wave is a periodic signal. It's a periodic signal. That is, a pattern repeats after every time period. It's a periodic signal. Okay, that is a pattern repeats again and again. Okay, so what is a digital time sinusoidal sequence? Instead of t we have n. Instead of t we have n. Okay, now the question here it is. See, so the period of the discrete time sinusoidal sequence, I'll show it pictorially. This is my that is a sine omega n plus phi, where a defines the amplitude at each instant of n, each sample n. At n, this value of n, it is having this amplitude. At this value of n, it is having this amplitude. Likewise, omega is the angular frequency, a is the amplitude, and phi is the phase difference. Here the phase difference is 0 because it starts at 0 itself. Okay, there is no lag. Okay, so see, what is the time period of such a signal? The time period n, there it was capital T, here it is capital N. It is nothing but 2 pi multiplied by an integer m divided by angular frequency omega. Okay, that is 2 pi multiplied by an integer divided by omega. Okay, so I can make, so this is an integer, n is also an integer, n and m are integer. So if I take n by m, that will be equal to 2 pi by omega. Okay, so n by m is equal to 2 pi by omega. Okay, so analog sine wave, you can easily say that it's a periodic signal. Can you say the same thing for discrete time sinusoidal sequence? Discrete time sinusoidal sequence, you cannot tell that it's a completely periodic signal. Every sinusoidal sequence, discrete time sinusoidal sequence, may not be a periodic sequence. They may or may not be periodic. Analog sinusoidal function was completely periodic. Okay, but for digital time, discrete time sinusoidal sequence, you cannot say it with confidence. It may or may not be periodic. So how can you say that this discrete time sinusoidal sequence is periodic, the other one is not periodic? Okay, so I told that n by m is equal to 2 pi by omega. So n is an integer, m is an integer. So an integer by integer is called a rational number. I hope you all understand what is a rational number. Any number in the form of p by q, where q not equal to 0 is a rational number. So n by m is a rational number. So this rational number is equated to 2 pi by omega. So this rational number is equated to 2 pi by omega. So if it should be periodic, then n by m should be equal to 2 pi by omega. This 2 pi by omega should be a rational number. A rational number. 2 pi by omega should be a rational number. But that is not a ready-made thing. Why? Because pi is an irrational number. What is pi? Pi is not 22 by 7. It is 3.14. It continues like that. So that is why pi is called an irrational number. Pi is a rational number. So n by m is not every time rational. Okay, the rationality of n by m depends on 2 pi by omega. So when will 2 pi by omega becomes a rational number? Only when omega is a multiple of pi. 2 pi by omega will be rational only when omega is a function. Omega is a multiple of pi. So suppose we have omega is equal to 2 pi. So pi and pi gets cancelled. 2 and 2 gets cancelled. N by m is equal to 1. So 1 is a rational number. Okay. So suppose omega is simply 2. 2 and 2 gets cancelled. N by m is equal to pi. That means n by m is irrational. Okay. So that means that signal is aperiodic. So a discrete time sinusoidal sequence to be periodic, and 2 pi by omega should be rational. That means omega should be a multiple of pi. Okay. So this much, with this much I conclude today's class. Thank you.